Good afternoon. My name is Shayna Cooper. I run product and marketing at Sample 6. Thank you for joining us for the first Sample 6 webinar. We are proud to present John Butts and his methodology on indicator sites. At Sample 6, we believe that sharing best practices is a critical component of making food safer. John's work at Land of Ross is certainly an example of best practice. Before we get started, a few housekeeping items. To ask questions either during the session or during the Q&A period, please type them in the dialog box in the GoToWebinar panel. If you have technical difficulties, check the GoToWebinar support site or give Kelsey from Sample 6 a call and she can help you out. For those of you not familiar with Sample 6, we are a food diagnostic company based in Boston. Earlier this year, we released our first products, Sample 6 Detect and Sample 6 Control. Our technology enables in-plant, in-shift pathogen detection and control. But what is the best way to leverage these tools? Well, that's where indicator sites come into play. So I'm proud to introduce John Butts. He brings over 40 years of experience in food safety. He is a leading author and educator on Listeria prevention and control. John also has extensive experience in product development, process improvement, and quality assurance. So without further ado, I'll turn it over to John.
Good afternoon. Thank you for joining. I hope we can shed some light on some of the sampling tools and techniques to help you strengthen your environmental control program. Almost everyone intellectually buys into the statement, the goal of the sampling program is to find positives. We've all heard, if you're not producing some positives, then you're not looking hard enough. Just where are these right places we want to sample? We do not want to know we do want to know our program is working, but we certainly do not want to find it on product or contact surface. This means we have a serious problem. So help me understand. Just where are these positives you're wanting to find? Unfortunately, positive samples in your routine monitoring program indicate that your pathogen control program is not working. Where do we need to sample more and harder to find these positives that tell us our program is working and not failing? We intellectually accept the ubiquitous nature of Listeria. We recognize that some plants with advanced equipment and facility design have a greater ability to control the exposed product environment. So, an effective sampling program will yield positive results. Positives must be treated as a success because they enable corrections that can protect our consumers. By our own definition, this is not the program we want to find positives. A verification monitoring program is a program that verifies the effectiveness of the plant's ability to prevent product contamination from an environmental pathogen. It is used for regulatory compliance. It's part of a USDA establishment's HACCP or SSOP program. For FDA plants, it measures the effectiveness of the preventive controls deployed. In high-risk production, contact surface sites should be evaluated on a weekly basis. Lower risk lines may be evaluated less frequently if the process is under control. In USDA plants, the guidelines and expert recommendations recognize food contact surfaces as the primary verification sites. These food surfaces will be sampled more frequently than product. It stands to reason if samples are taken at sites where accumulation occurs, they are more likely to be positive than product. FDA recognizes the high risk associated with contact surfaces and expects corrective action resulting as positive. The inference from both agencies infers a contact surface positive to be a failure of the plant's preventive controls. We also have Zone 2 and Zone 3 verification sites. Verification sites really detect the organism as it's being moved from its harborage location to a contact surface or the product. If an exposed surface, however, is a harborage site, then our pre-op sampling should be used to measure the effectiveness of the sanitation process. For example, a damaged plastic container or cloth back conveyor belt are issues that could generate a pre-op positive. Exposed surfaces in zone 2 or 3 are typically thought to be located in transfer pathways and not growth niches or harborage site. Now, the key word here is exposed. So as we move on, let's look at some examples of zone 2 and zone 3 verification sites. Low-risk sites that are never touched by mobile equipment, materials, or employees are poor sites to routinely sample. Risk analysis should be used to identify the ideal Zone 2 and Zone 3 sites. Both agencies like to see a broad scope of sites in the establishment's verification program. However, once pathways are known and established, then sanitation proven to be effective, that means pre-op of 0, then transfer pathways become the ideal sites. An ideal Zone 2 site can be defined as a secondary contact surface, one that is touched before a contact surface is touched, or a common location that can be touched by a worker that will subsequently touch a contact surface. Classic Zone 3 sites are surfaces in transfer pathways that people or equipment traverse. An example we use for Zone 3 sites are the tops of drains. So again, we're looking at an exposed surface, and items that are transient that move around the facility are also ideal sites to sample in our Zone 3 program. Next slide, verification monitoring. Verification and its associated corrective action when a positive is found is often the entire program for most plants. The verification monitoring program then will consist of product, Zone 1, Zone 2, and Zone 3 sites. These sites are routinely sampled, typically with some randomization of selected sites or randomization of time sampled. Positives produced by this program, by definition, are to receive some form of corrective action. The verification program, this is your written documented program, also defines product action to be taken if repetitive contact surfaces are found to be positive. And this is true in both agencies. Verification of corrective action or requalification of the prior positive site is typically 3 negatives in a row. So verification and corrective action data are mandated to be shared with the appropriate regulatory agency. Well, let's see where Listeria comes from. Actually, 2 sources of Listeria in the RTE area exist. One is a visitor coming from Zone 4. It's homeless and looking for a home. And sometimes we can provide that a home during the rinsing process when we can embed or impregnate the organism deep within a piece of equipment during the sanitation process. The other source is the Listeria as a resident. It has found a home in equipment or facility. Routine sanitation practices should eliminate the organisms transferred into the high-risk RTE area. A verification program positive may occur then from a visitor, one is transferred in from Zone 4 during operations, or a residence that is sloughed off from its harborage site and is in the process of being transferred to a contact surface or product. And this seems to be true. For some reason, the destination of their journey tends to be the product or to become impregnated into a protective growth niche.
let's look at sampling. As you see, this is what we would typically find in a 24-hour day in a typical meat plant that has sanitation for one shift. As you see, we have production through most of the day, then we go into sanitation. These are the typical steps most of us are using for the sanitation process. So the questions become, when do we sample? What are our sampling objectives? These really define our sampling program. Well, the first is transfer points. As you notice, these transfer points are occurring during the normal production process. And typically, I'm willing to wager a little money here that most of you do most of your sampling during this period of time. This is when we make our verification sampling. This is when we take our verification sampling during production. So we're trying to find the organism in movement from its growth niche or from outside the RTE or exposed product area into the exposed product area and ultimately to a contact surface or to the product. The other place that we can sample is right after the sanitation process. Here we're measuring the effectiveness of sanitation. If your verification program has a lot of samples during pre-op, then the question is, are you really looking to find the organism? If you're getting positives at this step, then it's time, folks, to come in at 2:30 in the morning and really see what's going on during sanitation. This process is and should be capable of eliminating all the organisms that are going to be on the surface of our equipment and facility at pre-op. So, sanitation pre-op, samples taken, verify the effectiveness of the sanitation program. They don't tell us a thing about our process control system once we get started. They don't tell us anything about how the organism is really moving around from a growth niche to find its way to the product. A necessary component, but should not be a major part of our sampling system. The next is growth niches. We look for growth niches by definition after the sanitation process has taken place and before we start operation. So look at it this way. If we have a positive after sanitation and before production, by definition, that is a growth niche. If it's Listeria positive, then it is a harborage site. So this is the key to the investigation process we call seek and destroy. So looking at this, where's the ideal place to find Listeria? At what point in time do we sample to find the organism? Right here. After rinsing and before chemical is applied. We've ran the process all day long. We've moved the Listeria as much as we can. Then we've done our pickup. We've disassembled the equipment, so now we're exposing surfaces below the normal level of sanitation. So if we have them coming out from a growth niche but haven't yet reached a transfer point, then we can find them here. So we come in and we rinse. We remove 90 to 99% of all the organic matter, and we create spatter on the sides of our equipment. This is where we have an optimal time and place to find Listeria. So this is the post-rinse sampling. So let's look at our programs again. The typical drivers for control on most programs are verification monitoring, followed by verification positives, for cause investigation, and then we hopefully gain some level of control. I don't think that's the ideal way of doing it. The effect of verification-driven control in this situation creates a food safety system failure. It is our primary responsibility in quality and food safety to create and apply measurement systems. We create the operational definitions. This control pathway is of our own making. We are responsible for the motivation and food safety cultural effects of our measurement systems. Failure is not the best motivator. So by definition, system failures from a verification-driven program are our responsibility. I think there's a better way that we can create positives to be a success, and that's using indicator sites, as we indicated earlier in this presentation. We want something that's going to predict the loss of control before it reaches the product or a contact surface. So let's look at it this way. We can have not for cause investigation followed by indicator sites and use that system to be in place before our routine regulated program of verification monitoring and for cause investigation. So I believe we can attain a better level of pathogen control if we add these elements prior to our traditional verification. Isn't that cute? I'll tell you, the folks at Sample 6 here are pretty good with graphics too. Let's look at this. We start out with a not for cause investigation. We then do indicator sites. My graphic wasn't nearly this good, okay? And then we get into our regular Zone 2 and Zone 3 verification monitoring, for cause investigation, Zone 1 contact surface monitoring, for cause investigation if we have a contact surface positive, and all of this leads to product control. So let's think about this. We have a tiered approach here, and with product being the thing that we're trying to reach the most in contact surfaces before that. Well, let's look at this again. The foundation of an aggressive, preventive, and predictive environmental control program then starts with not for cause investigation, followed by indicator sites. So properly implemented, these sites should detect problems before verification positives occur. That's the concept of the indicator site sampling program. So let's look at the sources of for cause investigation. They can be samples taken after an indicator site positive. They can be samples taken to find a new growth niche. They can be samples taken to find a new transfer vector. They can be samples taken to establish or qualify a hurdle or barrier system. These samples that we're taking, these investigations that we're doing, are not for cause, so they're not driven by a verification positives. We're doing this out in front to find things. So we may want to investigate to establish a new monitoring procedure or process. The key is taking these samples to identify an indicator site. Also, we can use them to assess or characterize risk of a control procedure. We all know that one of the things that we must do is use risk and data to manage our system and make changes based on that. Well, let's move forward here. Let's look at our traditional environmental control program again. We start out with verification monitoring. If we have a positive, we're at a high risk level. That's a Zone 1. First thing we do, document, let the folks in the agency know that we've had a system failure. Now we must find a root cause. The tools that we use for this are the seek and destroy process and the SWAT team process. I don't really have time to go into these, but you can search Food Safety Magazine. We published Seek and Destroy back in '03, and I think it's the April edition of that magazine, an article on that. And also, you can Google my name at Land DeFrost, and you can find several of our publications on this type of investigative sampling. Basically, you start after sanitation, before operation, and you take the equipment apart, observing and sampling. We measure for both Listeria and APC. If we find a Listeria positive, we have found a harborage site. If we find high APC, we found a growth niche. So we do this, or we can do what we call SWAT team sampling. Then when the operation is not running, we come in and sample surfaces that are not commonly found or not commonly sampled in our normal routine program. So you take a high number of samples here, and every now and then you're going to find some strange things to be positive. The next would be a zone 2 or zone 3 failure. Again, coming from our verification monitoring program, we're going to call this a medium risk level. Again, if we find one in our verification program, we're obligated to notify the agency. Here we conduct a time study because it's our belief that growth niches are harborage sites, and we take the equipment apart to find growth niches. It's not our expectation to find an exposed surface that is cleanable and is being cleaned, and we have pre-op negatives to be a growth niche. When we typically find a zone 2 or zone 3 positive, we're finding the organism in movement. So we have to use a time study. Some people will use a 360, start walking around in circles. I kind of think that's what you're doing a lot of the times, walking around in circles. You can find it, but let's stop at that point, or start at that point, that we found the positive. And at pre-op and then subsequently after that, we just simply sample everything that comes to that point in the process. We sample operator hands, we sample operator tools, we sample maintenance tools, we sample things that are carrying equipment, things that are carrying product. We try to find the source that is bringing the listeria to it, and then that helps us define the transfer vector and the transfer pathway. Then we move backwards in the process. Flow charts are often really helpful to help us do this study. So let's put it all together. We have verification monitoring, A positive, it can be zone 1 or zone 2 or zone 3. By definition then, we are not running when we do the seek and destroy or the SWAT team sampling, but to do the study here, the time study, we have to be running. So that really tells us there's two primary conditions in doing listeria investigation. One, there's a growth niche on the equipment, and it can then get to the product without a lot of transfer. Or the system has to be running to move the organism that is not directly associated with the line to the line to create that contact surface or zone 2 or 3 positive. So those are two primary things you look for. A, growth niche, it's on the line. B, the organism being transferred to the line. So it's your choice now. Which path do we want to go down? Do we want to go down for cause, the hard way, or do we want to take the easy way and do the not for cause? Let's look at the not for cause investigation. So we're going to do a not for cause seek and destroy. Again, it's being driven by your intellectual curiosity. Let's say we find a positive. Again, if we're doing seek and destroy and we have a positive and it's after sanitation, before operation, we have found a harborage site. And we're going to monitor. We're going to define an indicator site there. The other neat thing about this is it's low risk, and we've got this equipment disassembled. We now apply an intervention. By definition, that's what we do during the seek and destroy process. Everything that comes off that piece of equipment is either sanitized to a point that we know we've killed an entire population, or I like to heat treat things, put them in a COP tank. We put things in a smokehouse and cook it. So we document the intervention that's been applied. We likewise treat the framework of the equipment to a level of having an intervention. And it's my recommendation that we have an intervention treatment for every piece of equipment we have in the exposed product area. So the not for cause, if you find a harborage site, you now know it, you eliminate it when you put the equipment back together post-treatment. So this is a good situation. So now that we know where that harborage site's at, we have either eliminated through preventive action, We've developed an intervention and process control procedure. We identify that indicator site and we monitor that at some defined frequency with both Listeria and APC. If we get a positive or we get high APC, we apply the intervention. So we've now created preventive action and predictive action. I look at these are two key things that we need to accomplish in our Listeria programs. As you can see by my logo, awareness, enlightenment, preventive, predictive. When we can get in these preventive and predictive phases, we then can truly eliminate firefighting in our system and really get ourselves to a high level. And it enables us to have aggressive sampling that way too, without a high risk of verification positives or system failures. We can really get motivated when we can have a team go out in a not-for-cause situation and find a growth niche. That is truly a real thrill for the investigation team. So let's go back and look at some of these indicator site systems. Post-rinse, as we talked about in our little circle of the process, we do dry pickup, disassembly, the initial rinse, and at this point we pull samples, and we then apply chemical after that. So this is how we're doing the post-rinse sampling. So the thing that I like about, and really was one of the root causes that caused me to develop this, was we have a lot of sanitizer and dry quad on the floor. I was concerned, is that interfering with my sampling? So by sampling at post-rinse, we've eliminated that interference. So we know there's a pretty good likelihood that we haven't introduced a sampling error. Other environmental contaminants, such as fat or grease, are typically not present at this time too, because we're going to use hot water, guys, and rinse that stuff down. Other organic product debris has been removed. So we really have a good place to sample from an interference standpoint. Gives you a high confidence for the test. Equipment, therefore, is disassembled, and we can get any sloughing off that may be occurring deep within the equipment and before it gets outside to be transferred to that super highway that leads to the product or a contact surface. So that's sort of the theory behind post-rinse sampling. Post-rinse is not our only indicator site, so we have many others. We can go from a zone 4 to a zone 3. That's coming in. This is where the employees will come in. We'll sample that zone 4 area, measure our risk, then we're able to measure the strength of the hurdle. So our zone 3 sample then would be taken as we approach or get into the exposed product area. I would then have a verification site a few feet away from that. So in other words, we're creating that zone of control associated with a hurdle or a barrier. Other systems will be a zone 4 to zone 3 barrier with penetrations. We have a wall that separates in a meat plant raw from cooked. That wall has to have some holes in it to get product through. And likewise, we've got to get equipment and rework back into the raw area. So there are penetrations. So we're going to set up indicator sites around those areas to just assure us that our process control system is working. Here's an example of some problems we've seen. In the raw area, you can have smokehouses, various cooking methods, water cook. You can end up with a hot area. You can end up with a lot of steam. If you have a hole in that penetration in that wall, steam can go through even though you have a higher pressure in the RTE area. Steam is real interesting, particularly when you aerosolize in the hot area. I've seen steam pass through small holes in the barrier wall, go up to the ceiling, go across the ceiling, come down under a door, and then ultimately condense in a cold room, a cooler for instance, and it always condenses in a point that's directly over exposed product, of course. That's the way it works. But it's just amazing how far this steam and these conditions over time can move that organism. The other thing we can see is a conveyor passing through an interior wall where we're moving product from one area to another. Walls are a classic facility problem that can become positive. And the way we protect the product and the conveyor from the wall, the material that we use to go around that hole often isn't sealed, and that can be a great source of product or listeria coming out and getting on the product. The other thing we got to do is make sure that we're not sampling a zone 1. So you have to be creative in your selection of indicator sites, but please don't use a zone 1 site as an indicator site. That is a verification site. The neat thing about this is the thought in identifying indicator sites really helps you, the investigator, understand pathogen transfer pathways and vectors of movement. We've spent a lot of time in debate over where the exact location that we would put an indicator site. In fact, back in the early days, I wouldn't develop a new indicator site unless I had a long talk with my attorney. I just wanted to make sure that what I was doing was legally correct. And I may encourage the same of you as you develop this process. And I am not an attorney, okay? So the other system that we want to look at is the post-rinse. Again, it's a broader system of control. We sample large areas that collect spatter. We composite. I mean, put five sponges together. You can cover a lot of area, and you're not necessarily limited to that 12 square inches. You know, you can get a lot because we do not have a lot of debris that we're accumulating on those sponges. So we can increase our sampling efficiency. Now, positive results are going to direct us to a line or a pair of lines sometimes, depending on how close your lines are, or maybe just a section of a line. But it is not going to be specific to a machine, typically. If you get a positive, we don't have to ring bells, no fire alarm goes off, because it is such a general site, and it can be coming from that zone 4 visitor. So we're going to sample that line 10 days in a row to determine if that listeria spotting is repeated. If another positive is found, then we roll up our sleeves and we do that not-for-cause investigation. So our ideal drivers of control then become a not-for-cause investigation, followed by those control steps that we can put in place, including indicator site monitoring, and then our verification program. So I'd like to conclude with, you know, guys, growth niches can be identified and eliminated or managed. Transfer points can be identified and their effect minimized with good manufacturing practices. Aggressive sampling techniques such as post-rinse and other indicator-type sampling can aid in discovering problems before contact surfaces or product is engaged. And sampling programs truly can be designed to create a success when positives are found. So I thank you all for listening, and go into questions.
Thanks, John. We'll go through some questions that have come in. John, what's the one question that's came in is, what's the first step in building your indicator program?
The first step in building an indicator program is having a thorough understanding of the process. I really like to see things flow charted and mapped out, put on a map, and really identify those transfer pathways. Observe movement of people, equipment, and materials. I made a statement earlier that they all seem to end up in a contact surface or product. Well, there's a reason for that. That's where we're doing all of our transferring. So once you have a knowledge for that, then that'll help you better locate those indicator site samples.
Great, thank you. Another question that came in was about resources. So, John, how do you balance between your verification efforts and your indicator program?
As your program matures, you will find that you will be doing more indicator site sampling and less verification site sampling. One thing that really costs a lot of money, as you'll find as you're doing this, is those for cause investigations really get expensive. And you'll end up doing a lot of sampling in for cause investigations. So the goal of an indicator site program is to move that to a less intense, not for cause investigation, and we can do that on our own time. We don't have to be driven with the regulators looking over our shoulder. So as it evolves and your listeria positives and for cause investigations go down, I replace that money with not for cause and indicator sites. Actually, you'll find a good balance at about 50-50, and then as you move more into that predictive stage, you'll find the need to do less and less verification sites because you'll now have things mapped, you'll have your risk established. So ideally, a company that's in that preventive and predictive stages is going to do more of this type of sampling than verification sampling.
Great. Another question that came in is from Carla. In the event to find a positive during this step, after rinse, before chemicals applied, do we show this to the agency as well? So this is really a question around regulatory. So should we keep a separate record of investigational sponges? How do you handle this from a regulatory perspective?
Well, as I told you, I'm not a lawyer, number one. And there's been a lot of changes take place in the regulatory community and need since. If you ask any regulator, FDA or USDA, they're going to tell you, yes, I want to see that data. Is that something, if I'm in a USDA plant, I want to show my local inspector? Probably not. So I think what the agency has done, however, in their new risk-based inspection process, you know, we all have those risk numbers. Each facility has one with the agency. The more of this you share with them is the better. So I'm not going to say whether you should or should not share. If you've had an event, if you've had a positive product or a recall, you may be mandated to share everything. Personally, I have not shared this locally, but you know, we've not had a situation that's caused us to. But you know, when I go into negotiation, I always like to have a lot of stuff in my hip pocket. And if you can think of it that way, that's really good. So I leave it to you and your own establishment to make that decision. There are advantages to sharing that data. The key is make sure that you have effective and swift corrective action. And if you choose not to share it, you just, you know, you have a written verification program at your pathogen control program. You're going to show them all that data. So now, not for cause sampling does not occur after you've had a positive. So, you know, you have to carefully craft how you're going to do this. But I encourage you to use the tool because it really works.
Great. And I encourage all of you to reach out to John. His contact info is on this slide, and we'll also send it out in a follow-up email with any further questions and for assistance in your plants. John, thank you so much for your insights on indicator site testing. And thank you, everyone, for the great questions. The open dialogue across the industry is so important. I'll take just a few minutes to give a bit more detail on Sample 6 and our tools, and then share some information on some upcoming events. Sample 6 has the tools to help you build and track your verification indicator programs. Sample 6 Detect is an assay delivering an immediate actionable data, and Sample 6 Control is real-time mapping and comprehensive analytics platform. Sample 6 Detect focuses on delivering actionable results in a single shift. Our first product is for Listeria. So with a few minutes of hands-on time per sample and a short 6-hour incubation, results are available within 1 8-hour shift. We also put a tremendous focus on ease of use. We took advantage of currently used materials and processes wherever possible. Using a standard spongicle, environmental samples are collected. A short processing step is required before the 6-hour incubation. We centrifuge to clear large debris and then place the sample in the Detect reader for results. Detect is built on the bioillumination platform developed by our founders at BU and MIT, and here's how it works. Bacteriophage are highly specific to their targeted pathogen. As I mentioned, our first product is for Listeria. The bacteriophage have been engineered so that instead of simply producing copies of themselves when they interact with Listeria, they produce an enzyme like the firefly or deepwater shrimp that generates light. We detect this light with the sample 6 reader and can see a single cell. Sample 6 control was built to help manage the influx of data that you generate in environmental monitoring. So we focused on improving visibility and communication across the organization. There are 4 components to sample 6 control: plan, using our scheduling model and dynamic floor plans; test, using sample 6 detect, or actually any other environmental test. We firmly believe in being an open system. Remediate with an automated yet customizable process, ensuring all members of your team are informed and all actions are carefully recorded. And lastly, analyze the results so patterns can be understood and overall improvements can be made. Thank you again for joining us this afternoon. We firmly believe that together we can make food safer. We invite you all to join us for our 2nd annual breakfast at IAFP. This year we will feature David Atchison of the Atchison Group, Will Daniels of Earthbound Farm, Joan Menke from Conagra Foods, and Ruth Petran from Ecolab. In addition, be sure to catch our Director of R&D, Jason Bowers. He will be presenting on the field and lab performance of Detect-L, the Listeria assay, at 4:30 on August 5th. Thank you again for joining us, and we hope to hear from you soon. One question that just came in, is Sample 6 a lab? No, we are a diagnostic company, but we do partner with third-party labs for both our verification, and our product can also be used in both a plant and a lab environment. Thanks, everybody.